Hey guys, in lecture 4 we have discussed DFT and IDFT equation. In this lecture, that is lecture 5, we are going to take up few DFT problems. Okay, first few problems I'll take simpler problems, and later on we will make it bit complicated. Fine. So the first problem, I need to find n point DFT of x of n is equal to delta of n. Unit, what is this delta of n called as? It is called as unit impulse function, right? Okay, so how many point DFT I need to find? I need to find n point. So they haven't told us to find 2 point or 4 point or 8 point. Generally I need to find its n point DFT. Okay, and the signal x of n in time domain is unit impulse function delta of n. We'll try to take up this problem. So solution. So before we take up the problem, how delta of n is defined? Delta of n is defined, it is 1 for n equal to 0, and it is 0 n is not equal to 0. In the sense, it is defined only at n equal to 0. And what is its value? Its value is 1, right? So this is delta of n. Fine. So what is the DFT equation? So it is given by DFT of x of n. What is x of n? X of n is the given sequence, right? So how do we call it as capital X of k, right? So DFT of x of n is x of k. So which is equal to, what is the formula? Summation x of n, where n is varying from where to where. How many samples I have to take? 0 to n minus 1, right? So on the basis function e power minus j 2 pi by n into kn, where k is varying from where to where? 0 to n minus 1, right? So this is as per the DFT equation. So x of k is equal to summation n varying from 0 to n minus 1. What is x of n? X of n is delta of n into e power minus j 2 pi by n into kn, and this is equal to summation. So delta of n is defined for at n equal to 0, right? It is defined only for one value, which is n equal to 0, and its value is 1, right? So what I'll do, only at n equal to 0. So this summation holds good only at n equal to 0, right? So delta of n e power minus j 2 pi by n into kn. So in the next step, so I'll apply this n equal to 0 to this equation, and I ignore summation. Okay, so delta of 0 into e power 0, because n is 0, right? So e power 0. So 0 into anything is 0. And what is this? What is the value of delta of 0? It is 1. What is the value of e power 0? It is 1. So this is equal to 1, right? So for k varying from where to where, I have to carry on this k in every steps. It is 0 to n minus 1. So therefore DFT of x of n, which is equal to delta of n, is equal to x of k, which is equal to 1. Fine. So DFT of, what is DFT of delta of n is equal to 1. We'll take up one more problem, second problem. Here x of n is unit impulse function shifted right n naught time. So delta of n minus n naught. So what do I need to do? I need to find n point DFT for the signal x of n is equal to delta of n minus n naught. We'll try to take up this problem. So solution. So before we take up, we have to see what is delta of n minus n naught. How is delta of n minus n naught is defined? So delta of n minus n naught is defined only at, it is 1 only at n is equal to n naught, and it equal to 0 for n not equal to n naught. Okay, in the sense, so if this is 0, if this is n naught, and if this is n, it is defined only at n equal to n naught, right? And is 0 otherwise. Fine. So DFT of delta of n minus n naught, right, is equal to summation which is what? X of k, right? This is x of k, which is equal to, sorry, so this is DFT of x of n, right? So DFT of x of n is what? X of k, and what is its formula? Summation x of n, where n is varying from 0 to n minus 1 e power minus j 2 pi by n into kn, where k is taking the value 0 to n minus 1, right? So this is equal to, so summation n varying from 0 to n minus 1. What is x of n? X of n is delta of n minus n naught into e power minus j 2 pi by n into k into n. Okay, so this is equal to summation. This delta of n minus n naught is defined only at n equal to n naught, right? So it is defined, this summation holds good only at n is equal to n naught. So delta of n minus n naught e power minus j 2 pi by n into kn, right? What I'll do, I'll apply this n equal to n naught to this equation and I ignore the summation. What do I get? Delta of n naught minus n naught into e power minus j 2 pi by n into k into, so what do I need to do? N is equal to n naught, right? So it is n naught, right? Okay, so this is equal to, what is n naught minus n naught? N naught minus n naught is 0, and what is delta of 0? It is 1, right? So it is nothing but 1 into e power minus j 2 pi by n into k into n naught, and for k varying from 0 to n minus 1. So this is the DFT of delta of n minus n naught. Okay, so this is DFT of delta of n minus n naught. Okay, next, third problem, x of n is equal to e power minus j 2 pi by n into k naught into n. So I need to find n point DFT for the signal x of n is equal to e power minus j 2 pi by n into k naught n. Okay, so solution, x of k is equal to, what is the formula? Summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into k naught n, where k is varying from 0 to n minus 1, right? So x of k is equal to summation n varying from 0 to n minus 1. What is x of n? X of n is e power minus j 2 pi by n into k naught into n, and left out term is e power minus j 2 pi by n into, okay, this is k, right? I'm sorry, k into n, to where k is varying from 0 to n minus 1. So x of k is equal to summation n varying from 0 to n minus 1 e power, what I'll do, I'll take minus j 2 pi by n into n common. So e power minus j 2 pi by n into n, e power minus j 2 pi by n into n, both are common, so I'll take common. So what do I get inside the bracket? If I take e power minus j 2 pi by n into n common, it is k, right? E power minus j 2 pi by n into kn, e power minus j 2 pi by n into kn, k plus k naught, right? So if I split this, e power minus j 2 pi by n into k into n, which is this term, and next term is e power minus j 2 pi by n into k naught n, which is this term, right? So for k varying from 0 to n minus 1, what I'll do, x of k is equal to summation n varying from 0 to n minus 1. I'll take this n to the numerator, e power minus j 2 pi by n into k plus k naught, right? Whole power n. So I can do that, right? Okay, now, so we know this standard result, right? What is this summation n varying from 0 to n minus 1 alpha power n? This is equal to what? 1 minus alpha power capital N divided by 1 minus alpha. So where alpha is not equal to 1 and it is equal to n for alpha equal to 1. So this is a standard result, right? So I repeat again. summation n varying from 0 to n minus 1 alpha power n is what? 1 divided by alpha power capital N divided by 1 minus alpha. This condition holds good only for alpha not equal to 1, and it is equal to n, and this condition holds good only when alpha equal to 1. Okay. Now what is alpha here? So summation n varying from 0 to n minus 1 alpha power n. So this whole term is alpha, right? So e power minus j 2 pi by n into k plus k naught is alpha, right? Now so alpha equal to 1 implies okay, what is this in terms of k? For what value of k this entire thing which is alpha becomes equal to 1? I repeat again, for what value of k this entire thing alpha becomes equal to 1, because I want to write in terms of k here. I cannot write in terms of alpha, I have to write in terms of k, right? So this you might say, for sir k, for k is equal to minus k naught, this becomes equal to 1, because k minus k naught plus k naught is 0, so e power 0 becomes equal to 1. So you cannot say like this, because what is the definition says? K is varying from where to where? K is varying from 0 to n minus 1. K takes only value 0 to n minus 1. It does not take the value minus k, negative value. Okay. So this if you are thinking like this, it's wrong. K does not take the value minus k. So for what value of k this alpha becomes equal to 1 then? So this is for when you put k is equal to n minus k naught. When you put k is equal to n minus this alpha equal to 1 implies k is equal to n minus k naught. So this right hand side of this becomes equal to 1. How do we get this? If you put k is equal to n minus k naught, if you put k is equal to n minus k naught, minus k naught plus k naught cancels out. So I end up with e power minus j 2 pi by n into n. I end up with e power minus j 2 pi by n into, right? So what is that? N minus k naught plus k naught, right? So these two cancels out. So now again these two cancels out. What is e power minus j 2 pi? This is equal to 1, right? Correct, no? So therefore alpha equal to 1 implies k is equal to n minus k naught. Okay. Now alpha equal to 1 is done. When alpha is not equal to 1, implies for what value of k in this equation this is not equal to 1. So for k other than n minus k naught, for any value of k other than n minus k naught, this right hand side of this alpha will be not equal to 1. Okay. If it is difficult to digest, you just sit and think about it. Okay. I hope this is fine. So let me continue with this. Okay, let me apply this result in the next step. So what do we have? X of k is equal to what? Summation n varying from 0 to n minus 1 alpha power n, right? In this kind of equation. So what is the right hand side of this? 1 divided by alpha to the 1 minus alpha power capital N divided by 1 minus alpha for alpha not equal to 1 and equal to n for alpha equal to 1. So I'm going to apply this result in the next step. Okay. So what do we have? X of k is equal to 1 minus alpha power capital N, right? What is alpha? Alpha is this entire thing. So it is e power minus j 2 pi by n into k plus k naught divided by 1 minus alpha, right? 1 minus alpha e power minus j 2 pi by n into k plus k naught. So this is 1 minus alpha power capital N, right? So this entire thing to the power capital N. I can take this capital N inside, so I can take this inside, right? Okay. Now what is this holds good for alpha not equal to 1. But what do you mean by alpha not equal to 1? What is this in terms of k? It is for k not equal to n minus k naught, right? Correct, no? No, and it is equal to n, for alpha equal to 1. What alpha equal to 1 implies what? K equal to n minus k naught. Correct, no? Now, so what happens to this equation? This n cancels out, no? So if this n cancels out, what is this? E power minus j 2 pi into k is an integer, plus k naught is an integer. Integer plus integer is an integer. So e power minus j 2 pi integer multiple of 2 pi of this is always 1, right? So this entire thing is equal to 1. I repeat again, k is an integer, k naught is an integer, integer plus integer is an integer. So e power minus j integer multiple of 2 pi, because this is an integer, will be always 1. Okay, so 1 minus 1 is 0, 0 divided by anything is 0. So what do I get is x of k is equal to, let me write it here, x of k is equal to 0. So this term is 0 for k not equal to n minus k naught, and equal to n, and is equal to n for k equal to n minus k naught. Okay, so this is basically, this is the DFT of, this is the DFT of what? X of n is equal to e power minus j 2 pi by n into k naught n. But I can put this in a compact form. Instead of writing in a complicated form, I can put it in a compact form in terms of delta function. I can do that. So how do we do that? So x of k is equal to, so I can use delta function and write this equation. So how it is? So n into delta of k minus n plus k naught. Okay, how did I write this? So when k becomes equal to n minus k naught, when this k becomes equal to n minus k naught, so what happens? So plus k naught minus k naught cancels out, right? And plus n minus n cancels out, right? Plus k naught minus k naught cancels out, plus n minus n cancels out. I end up with delta of 0. And what is delta of 0? Delta of 0 is 1. 1 into n is n, right? So when k becomes equal to n minus k naught, I end up with n. So when k is not equal to n minus k naught, when this is not equal to n minus k naught, so delta of some integer value, what is delta of some integer value other than 0? It is always 0, right? So 0 into n is 0. So I get 0. So therefore, so DFT of x of n is equal to this e power minus j 2 pi by n into k naught n is n into delta of k minus n plus k naught for k varying from 0 to n minus 1.